appreciate CarolinaCon giving me the opportunity to come and speak. I've got a very hard act to follow with Mr. Joe McRae. So a little bit about me. I'm a network guy. I dabble in hacking, but I'm primarily a hardcore network security guy, building out telcos, utilities, smart grid, transport networks, optical, cable, MPLS, things like that. But I get into penetration testing. I do get into that, and when I'm involved with our team, I'm the guy that's figuring out how to go after the whole network architecture. I'm not the web guy, I'm not the database guy, I'm the network guy on the pen testing when I'm in that role. And basically what this presentation is about is everyone's talking about APT and talking about all these advanced threats and talking about you know, how whenever, it seems like whenever somebody gets hacked, they're blaming APT. And really when they're getting hacked with old school basics. And so I just come up with the term BPT to go out and lay out, this is what people really get hacked with. You might have somebody that has advanced skills in some cases coming, but a lot of the places I go, they're getting broke into by real basic things. Primarily what I'm going to really drive home today, that I try to with all my presentations, is the trust relationships. If you can go and get one little handhold and then start pivoting and exploiting the trust relationships and the interdependencies, you can take over, unfortunately, a lot of important networks. And a lot of it's because, you know, they're doing, you know, the old flat earth type architecture, et cetera, and not hardening things and disabling known defaults, et cetera. And so here's the new networks that are being rolled out for smart grid and broadband networks. At the top, what we have is the control network management type services, where you'll have your DHCP servers, your policy servers. You may have lawful intercept. That's basically IP-based wiretap. You got your AAA servers for aggregating, authentication for like your DSL PPOE. The automated provisioning, it might be automated provisioning in a telco. With a utility, it's going to be automated provisioning for smart grid. And the whole point there is for getting rid of truck rolls. So you've got an end-to-end connectivity from the internet all the way to the smart meter. And what happens there from provisioning for a utility is you can go online, pay your bill, and it goes and talks to the billing server, and the billing server doesn't talk to the SCADA system. They will turn around and talk to your smart meter and tell it to turn it off unless you don't pay your bill. If you don't pay your bill, the billing system can go all the way through the provisioning and talk to, say, a smart meter and flip your power on or off, no truck roll, which is great for green initiatives. But the problem is as you can see, as you move down through these different layers, there's all these different layers of dependencies. When you go from the network management layer at the top and you start going down into the transport layer where you have your MPLS, your IP, your DWDM, SONA, ATM, whatever that core transport network might be, all the way down into the distribution aggregation layer where you might be having passive optical networks, might be an active Ethernet where you're even rolling out GigE in some cases to homes, or it could be a traditional TDM SONET network. But the problem with all this is, and I want to drive home with some real example, is when you have all that end-to-end integration that's available, it works real smooth until somebody wants to target that network and take it over. And the big concern I have, and what I'm trying to educate everyone on, is we really got to go and nail down on the remote access that is inherently going to exist and built into these networks, because as you go through each layer, each manufacturer, what I see, typically is going to want to have remote out-of-band access to their system application. And a lot of times the organizations that are buying all this infrastructure, they have no idea about the threat that's out there. And so they sign the dotted line, sure, you drop your system in, and you can drop in your multi-home dual leg Windows box straight to the internet and bypass all my security because you're the vendor. You know what you need. I don't. And you assume that because they're the vendor, they're dropping in security. And then of course you got the threat of the internal tech staff that might get popped with malware and is going to have a trusted VPN back into the network, into this critical infrastructure, et cetera. Along the lines of SCADA, one of the reference architectures for ICS, industrial control systems, or SCADA, depending on the engineer you're talking to. If you're talking manufacturing, you want to talk ICS. If you're talking to utilities, you're going to probably more talk about SCADA. But the ANSI ISA 99 is a standard architecture of how we should look at building networks and securing them from an architecture standpoint. At the top, you've got the corporate network. You drop down to the next level to a SCADA, ICS, DMZ, and you roll down to where you'd have the core SCADA network, which rolls down to the next level where you'd have your RTUs and PLCs, and those are devices that actually control real equipment, mechanical type equipment, flip relays, flip switches, et cetera, on down to the real equipment at the very bottom. Now, this looks real good from an architecture standpoint. You got firewalls between the corporate network and the SCADA DMZ. I personally, in the utility space, when I say utilities, I'm not talking about the power generators. I'm talking about the distributors, municipal in this case. That doesn't exist. It may exist, but I don't see them. And in the firewalls between the corporate networks and the SCADA networks, I'm starting to see the firewalls put in places that are recommended here. But commonly, what you commonly see is, this is what it is. You guys, this audience is not going to believe this. An NT 4.0 box, multi-home, one leg in the corporate network, one leg in the SCADA. It's there, seen it. I talked to somebody the other day that had one, and they promised me they put a firewall in because I was on a redneck jihad. Like, have you done a firewall yet and got that box out of there? Please, just tell me you did. And so we'll see things like that. And at the same time, big holes in this architecture is over to the right in the center is the vendors will want to have back doors in because the engineers don't know those systems. They're just operators. And what will happen is if it's an old legacy system, there'll probably be modem back doors. Believe it or not, still in this day and time, modems, the old USB modems, they'll be back there, covered in dust. And hopefully they're being disabled when they're not in use. Hopefully somebody remembered to turn the thing off. Hopefully they did that. And there's a log that shows that who did it, who turned it on and who turned it off and what time, et cetera, hopefully. But what will happen though, in many cases, even with the modern systems, they're going to want a VPN to come in so that they can have free access into the network and provide support. And the big concern I have with a vendor having unchallenged, especially nailed up access or even dynamic VPN access is who is controlling that vendor and making sure that they're only in when you know they're in and monitoring their privilege and access while they're into the network. Because what if the vendor gets popped? And then they turn around and their trust in their system, their network, through their trust relationship, you're inheriting whatever vulnerabilities they have. If they get hacked, you inherited their hack if you don't have this connection locked down tight. Just some questions it's on my mind. No APT required for that hack. This is real life. You're not going to believe this. I was talking to a utility the other day, and I was working on being a telco transport guy. I was working on their Metro Ethernet network, trying to resolve some network issues within the city between some locations. And I started talking to the manager and asking him, so tell me about your SCADA network. Just throwing out some good questions, social engineering a little bit. I wanted, curious how the network was architected. And in faster than I could keep up with my eyes, he whipped out his phone, no passwords, pulled up his Android phone, hit DNC, and had his SCADA system right in my face. And never did I see a password. And my jaw dropped. I'm like, oh my God. I'm like, okay, I'm fixing to give you all the free consulting, for the love. You need help. I'm fixing to go do some charity work, and I'm going to work nights and weekends to help you get this cleaned up. And I started having this dialogue with, and I need to go back and say, this is after I earlier in the day already had a coronary because I had discovered on their firewall that their billing system vendor, it's secure because it's cloud, right? The billing system vendor put in a cloud-based system for them and dropped in a firewall for them, and you can't make this up. The firewall rules will permit any, both inbound and outbound. The only thing protecting that internal network was they were doing PAT with no static NAT translations. And I'm like, oh my God. And then he goes and does the Android trick with VNC to me, and I'm like, get the paddles out. As a network security guy, I'm on the floor here. I was like, like I said, everybody's talking APT. This is BPT. This is basics. I mean, just remedial basics. The news wants to talk about APT. We need to go deal with BPT, the basics in our energy problems. And the conversation I had with the manager, very professional, very nice guy, and I started trying to offer my services to him and give him some very free, what would otherwise be expensive consulting. He's like, we think this is secure. Got really challenged that I would even consider, question the architecture of the network. And I'm offering services for free. So that ended that conversation, and I was like, but part of the conversation he had with me is he's talking to me that the guys that work for him, they love it because when they go hunting, and I'm a big hunter, I'm a rabbit hunter, huge hunter, so I can appreciate this. When they go hunting and they're sitting in the stand, they can very easily monitor the SCADA system. There's no, they can just go pull out their phone and hit VNC, and there it is, and they can see how everything's operating. Everything's green's good. Yellow, need to call somebody. Hopefully, you don't have to call while you're still in the tree hunting. But yeah, what could possibly go wrong? So I'm going to talk a lot about the service provider side that is really marrying up with the utilities. It's getting really gray. The utilities are becoming service providers. The service providers are providing transport to the smart grid. It's all becoming intertwined now. This is an example network management architecture for a service provider where you got the network management users. You might have a network management system. If you have a specific vendor network management system, it's designed for specific device hardware. You'll call it an EMS, element management system, and you'll probably have a database underneath it, typically Oracle, that is been installed by the router guy. That has no clue about Oracle, but I'm a router guy, so I know everything, and I can take care of it. I can feed the CDs and get the database and the apps up, and so it's totally unsecured to all the standard defaults. And it'll be integrated with the network so that you can do the old Telcordia TL1 type protocol, talking to your transport TDM devices, say your SCADA, not your SCADA, but your SONET network, or doing the SNMP into your network architecture with northbound interfaces up into what we call the OSS operation support systems, which will have your provisioning and other network applications that will further over to the right that I don't show would have a northbound interface to the enterprise business support systems where the business operations are. Just to give you an overview of network management. Now, here's an architecture, an example inside these service providers. Like I said, the utilities, in many cases, are when they roll out the smart grid network, they're going ahead and rolling out fiber since they own the poles. And since they're rolling out fiber, they got all the bandwidth in the world, so why not go hot it up with internet, voice, and cable TV? Get into all these additional services. They own the poles, they own the fiber, why not? And oh, by the way, they can get bonds for 20 years, so they got 20 years to go pay off their investment. It's a good business plan. And so both your energy and the telcos might have something similar to this, where they'll have a SAW switch, and you'll have your main SAW switch at, say, your primary CO, and then you might have a backup SAW switch at a remote office just in case, of a tornado, fire, et cetera. You've got a backup capability. But one of the things that's interesting is the vendors are always going to want some kind of remote access into these networks, because if you go and drop in what we call a class 5 phone switch, which is a soft switch, phone switch is big enough to run a whole city, guys who are used to running power, putting in meters, they have no idea about running a phone company. But they in the business because they got the bonds, they got the money, they wrote the checks, they got it. And so what will happen is the phone guys are going to come in and provide top cover for them and keep the thing running. And they're going to want a good internet connection, a good VPN connection. And again, that's great and that's okay as long as that vendor doesn't get popped, or that traveling technician who is plugging his laptop into every telco utility and every other hostile network in the world wherever he travels. Lord knows what that laptop's picking up. And when you call, he's going to VPN right into your network, into your secure critical infrastructure network, and whatever's on his laptop could go and spread into your network. And what I have personally seen on multiple occasions, these networks get hacked, and they're getting hacked not by some kind of advanced APT. They're getting hacked by just SSH brute force. SSH brute force, unrelentless, nonstop SSH brute force. Because what they'll do is they want remote access. So wherever they're traveling, whoever the field engineers are, when you call, they can jump in and help you out. And so you can't set up a static, hard-nailed ACL that only a specific location can access that service. You've got to have it open up so wherever your field engineers are, they can reach you. Well, if they can reach you, so can Romania. And they're looking. And what I have seen is when they get popped, they'd only find out about it because in a lot of these cases, these connections, in some cases, may be multi-homed or may have a very weak firewall connection. And a lot of times they only find out after some bank in Europe calls them and tells them to cease and desist attacking them. Another example of just bad design, you can't blame it on anybody else. We're doing these things to ourselves, is these ring topologies. There was a time before I became a service provider engineer that I thought that ring met ring like the networks on the bottom where you had all this redundancy and it was a geographic ring. How naive was I? I'll never forget when my innocence was lost sitting in a meeting and we started going in and architecting this out, and someone drew out this architecture and explained to me the concept of a collapsed ring. Oh my word. And so basically what you have is for FCC, for emergency 911 services, you have to have a ring for redundancy because you got to have dial tone. If there's an emergency, the phone's got to work. So what happens is if you're in the service provider business, what you can do is if you don't have fiber ran between all your COs, geographically diverse in architecture because of cost, right-of-way access, et cetera, what you can do is if you can have one strand, one bundle of fiber, you can terminate it on both ends and then just electronically loop it on both ends. And it's called a collapsed backbone. The problem with this is I've seen this personally. There was some guys who needed some copper I'm sure it was for all the right reasons. They were going to buy medicine for their children or something, you know. They were really, really hard times. And some guys, they took it upon themselves to climb a customer's poles and cut the cabling running between the poles. They thought they were getting copper, and it turned out to be fiber. And so 2 cities are down until the fiber trucks can come in from 2 or 3 states over to go and resplice their fiber and get it back on the pole. Wasn't no APT there. It was just bad design, and maybe it was Bubba PT. Bubba persistent thread in that case. So here's another architecture, just basics, just basic architecture. Telco I had a network. They're offering all kinds of services, even offering transport services to smart grid. They're in the cable TV business. They're into voice. They're into internet. They're into all the name the service, cellular, et cetera. And they got a billing system vendor. And one thing that I've learned is whoever does the billing system, that is the trusted advisor, right? No matter how smart you are, you could be Mudge and fall off in that place. it tell them, thou network is not secure. You need to do this. And they will not listen to you. They will listen to the billing system vendor. So in this case, with the billing system vendor, sold them on that they could run their external online bill paying system on their internal bill paying system. And I'm talking about payroll, billing, you name it, it's all on this one system. Conduits all the way through the firewall to that system. We got brought in on this case to do a pen test, and we hacked the system. It was very trivial. Guy got some directory, web guy that works with me at the time, got some directory traversal, and I think he ended up getting a JBoss command shell on the box, and ended up totally owning the system. And from there, we were asked to stop, please. But what's really scary, the reason is, again, trust relationships, integration, interdependencies, that billing system, how things operate with provisioning. You go in and make an order, you pay your bill, don't pay your bill. All of that intelligence is integrated further over to the right into other systems, the operational systems where provisioning, network management and things those type of services are setting. And so from that billing system, we could have pivoted into the provisioning and monitoring part of the network, and from that just totally took over the whole network. The dominoes would have just fell. I have never seen it that we get that handhold and we get that access if we don't end up owning everything. A lot of times they'll say, please stop. You know, we got a board meeting we got to go to, and we'd like to have a job afterwards. Just stop now. But after that happened, we always go in and do a architecture recommendation, and we recommended the traditional, split out the DNS, split out the web services, put in a better internet-based architecture for online services. The billing system vendor won the argument. It's like, no, this is secure. So we've hacked them. We got pictures, screenshots, got the access, and we show them where we're fixing to go and take the whole thing over. No. Billing system guy says you're wrong, they're right. And it'll make you feel better. If it makes you feel better, the billing system vendor, I understand now, is in the security business. I mean, it's like, somebody hand me a Tylenol. I need an Advil. So here's another good one of just some basics. No flame, no Stuxnet, no nation state, Bubba. Just basics. Got a telco offering lots of services, cellular, voice, internet, data, cable TV, you name it. If you're buying it, they're providing it. And but what's really unique here is the transport vendor here in the middle, in the center of this drawing here. Their network architecture and their hardware is of such that they break the RFCs for multicast. They have VLANs that are dedicated for voice, VLANs that are dedicated for data, VLANs that are dedicated for cable TV, IPTV, basically IPTV multicast cable channels over the IP Ethernet network. So when you're hitting your clicker, you're changing IP multicast groups. And what they do, I discovered, as a result of this, I discovered that to make the channel changing very, very fast, they've got it programmed into the ASICs so that anything that gets multicast at the hardware layer. It's getting done in ASICs. It doesn't even wait to go through the whole IGMP and PIM process. If it gets put in that VLAN, it multicasts it in hardware and fires it out to everybody. So it's optimal to get rid of that software overhead. And so what happened is a gentleman accidentally, in this case, it wasn't nothing malicious, he accidentally provisioned internet into that voice VLAN, and with internet being an ISP, having that as service, he had thousands of users that were infected, obviously, with Lord knows what kind of malware of the month at that time, and provisions it over into that video network. And though it is IP ICMP traffic, because of the way that VLAN is designed into the hardware, it automatically starts multicasting. So I get a call on the road, this guy's hair's on fire and his tail's catching, my whole transport network's down because it's DOSing this transport network. And we start on the road, on the interstate, really had to pull over and start trying to get a network connection and start trying to sniff from the one place of the network that is up and say, what in the name's going on? Craziest packet ever seen. IGMP with ICMP encapsulated inside it. That was crazy. And we finally figured out what was going on and got that done. So again, just the basics. Took out that whole network, tens of thousands of people. But no Stuxnet, no Flang, no 10 years of development. And here's an example. This was recently in the news in South America. Our friends in South America experienced this, where they had, in their case, millions. Thank God it wasn't me that had to deal with that one. Somebody had to go deal with millions of DS routers that apparently got hacked. In this case, some people I know, it happened in 2 different cases, and this occurred a couple years ago. Because they did not have a strong control management and data plane separation of services architected into the network, so that the control plane and the managed plane and data plane were security locked down and monitored properly. An individual was able to write up some scripts and target all their DSL routers. One of the guys caught it really, really fast because he had a really good deep packet inspection monitoring capability, at least, though he did not implement good security all the way out to his subscribers. He did at least have monitoring, and he caught the attack pretty fast before he had thousands of modems popped by this adversary. The other guys, they did not have any monitoring. Their monitoring was the phone switch lighting up, and by the time they got done and realized what happened, they had 6,000 DS routers popped by somebody. And what happened in this case, the gentleman popped the DSL routers with some backdoor username passwords that were not secure, though the access to that username password, that whole management interface should have been locked down. They should not have been permitted to connect. So the guy was able to get in there, and he started changing their DNS config and redirecting them to a data center somewhere in the U.S., and then redirecting the traffic for sites of interest to his website. Who knows how much damage was done and to the customers, and what they lost in customers switching over to the competition. This is a strange one. I've only seen this once. Again, this goes back to that whole locking down the control, management, and data plane services all the way from your internet edge all the way through the core and distribution all the way down to the subscriber network device, getting it all locked down. In this case, had a enterprise corporate broadband customer started sending some weird BGP MD5 packets to a legacy BGP router that the customer had brought online. It was an old router, been sitting in the floor, and had a hot customer problem come in faster than a new router capability could be ordered and put in place. So, go and pull the old router out of the floor, put it back in place. And the reason I say it's legacy is it was an old, the reason they had pulled in is they needed to hot up a OC3 ATM connection, because they'd gone pretty much all Ethernet on their network, and that thing apparently has some old code in it, had a bug. But what was really interesting is somebody got popped. I hope it was a piece of malware. I hope it wasn't a customer employee that was deliberately doing this attack in this location. I would be surprised if they had that sophistication. But started sending this traffic directly at that legacy BGP router over on the right on TCP port 179, and causing that router to crash and taking out a lot of services, because that was supposed to only be a temporary service. But because they got thrown in a hurry, the router control plane was not locked down tight, so that someone like an internal subscriber could not go and launch an attack of this nature. And like I said, the user should not have been able to have ever done that to begin with. So that's a interesting basic attack. Here's one. Again, to get back on the vendors. I was at the utility when this happened, because I used to help build a lot of these head ends. I would put in the cable modem termination system. the CMTS, which is a fancy name for a cable router. If you talk to DSL guys, it's a BRAS. When you terminate DSL, a router turns into a broadband remote access server. And when you're talking to a cable guy, it's a CMTS, cable modem termination system. To me, it's just a router. But depending on who you talk to, it's very important that you call it the right thing. Though it's just a router with some cable interfaces on it. So I was there doing my router work, and this vendor had a nailed up VPN connection, had a router because they wrote it into their SIL, part of their project that they had to have a dedicated VPN back there to their office. Well, it turns out that looks like they got hacked through that trust relationship. Whoever popped them wrote across that VPN and popped the billing system integration capability they had on that local site. At that time, I wasn't into the hacking business, so I really didn't get the big picture about all the pivoting and things that could happen that I understand now, or I would have had a coronary all in between the racks over there at the time. But the guys just dropped in, wouldn't say anything, wouldn't tell anything, ripped out their server, dropped another one in, and one of the guys, I guess, had not been coached by management properly and said, we've been hacked. You know, and my question still to myself today is whoever got in there and did that, how much pivoting did they do before they got that system yanked out and got backdoors established into that network? I have not seen this scenario, but along the lines of that scenario, this is what a concern I have, that when we're as a community, security community, we're out building networks and testing the networks and trying to help our customers get them better secured. One of the concerns I have is since all these vendors are wanting these nailed up VPNs in many cases, if they're able to, if they end up getting hacked because of how these head-ends are in many cases are architected, what is to stop somebody from pivoting and not only attacking the service provider, whether it's a utility or a telco, pivoting off of the vendor, say vendor one, and pivoting into the utility and attacking their networks to stop them from pivoting and going back and heading back east or west into another vendor's network. Because in many cases, they're dropped into the same VLANs. There's no private VLANs. There's no VLAN ACLs. There's no segmentation in that network. It's all kumbaya. Everybody's packet can see everybody else's packet as far as connectivity goes. So that's a bloody nightmare waiting to happen. I mean, at least, even if you have a legacy network, and it's going to be very painful to go back and redo IP addressing and put in VLAN segmentation and layer 3 ACLs. There's no reason you couldn't go in and do layer 2 segmentation with private VLANs and do VLAN-based ACLs to establish some layer 2 segmentation and control the ability for an adversary to do pivoting inside that network and exploit trust relationships. Here's a real-world scenario I saw. It's bad. Oh yeah. The transport vendor in this case, they put in a network, built a really good network. The network performed really well, and they had a element management system, a network management system specifically for their hardware, and it was really nice. It had gave the customer a GUI of the hardware. It made it really easy for the customer to point and click and manage the network. The problem is that vendor had more political pull inside the company with the organization he was selling to than the guys who were running the internet side with all the security devices that understood the threat. And these gentlemen were able to install their multi-home Linux server with one leg into the core transport network and another leg bypassing this over $500,000 invested in security, hardware and software. And somebody discovered that system out on the web and did the SSH brute force to it, took it over, and next thing you know, somebody else owns the core transport for the whole network. Doesn't matter if the IP is secure, if your layer 1 and layer 2 are not secure. Things like this really get back to the inherent problem that we see is there's not a top-down driven security policy that drives how things are going to be integrated into the network. If you're going to bring a new system, new application, bring a new network service online, then it's going to adhere to a standard security policy and make all the vendors adhere to that. Now, here's a example architecture, reference for network management. When I'm playing on the pen test side, I really go after the network management piece since I'm after the network, because if we can get that, all the dominoes are going to fall. Doesn't matter what the end target is. So, but here's an example of a in-band network architecture for managing, where you've got the voice, video, data. Could be an enterprise. All the services are riding on the same pipe. The only segmentation is layer 3, maybe some VLANs to protect the network. And what I want to suggest, based on my years of experience and what I'm seeing in the wild, is to put a very strong focus. If this is the way you've got to architect your network, you're using in-band, is go to two-factor authentication and put a strong emphasis on logging everything when it comes to accessing your network devices and anything of privilege, and monitor and question everything. And put some really strong visualization instrumentation to, if anything out of the ordinary happens, that you have some telemetry capability to see it. Because if somebody's coming after you, it's a good chance they're going to go after those network management resources. You want that management plane of that network locked down very, very tight. And here's what I'd prefer to see. A lot of times this is not realistic. It's for budget, culture. I personally think a lot of it's culture, because network devices are a commodity now in price. But culturally, it's sometimes hard to get done. But in this case, this would be a more secure way to manage your network, is to use out-of-band connections, have your terminal server for out-of-band, have a lot of the routers and switches today and the servers have an out-of-band management capability. If you got HP, you got ILO, you got the Cisco's got the out-of-band capability on their boxes. Dell's got the D-Rack. There's no reason that you can't manage your devices out of band, so that if there's an adversary that's inside the data network, that they're not going to be able to jump the physical wire and get into the management network and take control of the whole network infrastructure. And that way your network monitoring, hopefully your CM system, your IDSs, your logs, et cetera, would be extremely secure, so that someone can't go and influence what you're seeing on in your logs and monitoring. This is, if I ever get back into the enterprise managing and running a network myself, this is the type of network that I want to probably try to architect. I've become very paranoid being in the business, and then going hanging out with people like Joe, I get even more paranoid every time I go to one of these conferences. Now this just shouldn't be so, but this is bad. But if you plug into a network today, typically the network's going to have one of the top vendors, if it's a network of any size, and it's going to be intelligent, it's going to be managed, it's going to support voice over IP, it's going to support quality of service, you're going to have all the knobs to turn for security, for multicast, et cetera. But I have yet to see one of these top dollar networks implemented where these basic layer 2 problems have been dealt with. If we can get physical access into the network, we never, ever see where the layer 2 has been properly secured. You can see the spanning tree happening on the network. You can do the ARP poisoning. ARP poisoning, you should not be, if you pay top dollar for a name brand network, you should have the port security set up with dynamic ARP inspection, or one of the other security methods that are available to stop that ARP poisoning attack. But wherever we go, it's there. Another one that's always there, if you got a really good network that's had a lot of investment, they'll have redundant routers in place. Whenever we see redundant routers, we see first hop redundant. Yeah, we hit it right there. Yeah. If redundant routers are in place, whether it's HSRP or VRRP, what have you, it's always out on the wire. I mean, if you're going to, and what's really sad is it's either no password on the authentication between the routers, or there's a password and it's clear text. If you had enough foresight, enough thought to turn on authentication, why not use MD5? I mean, how much harder would it have been to turn on MD5 if you're going to turn on authentication to begin with? But they never does. It's always clear text, and majority of the time the password is, if it's a Cisco network, it's Cisco. And it's sitting out there multicasting on the wire, and all you have to do is go and, you don't even have to be a Linux ninja with SCAPI. You can go and download something like Colasoft. You can download Colasoft and import your Wireshark capture and start pointing, clicking, changing parameters, and edit the text of your packet and create a new router and do a checksum and replay it on the wire and do a denial of service, or go and set up a outbound man-of-the-mill attack. Very, very simple. And what Joe just referenced with that BPT guard, we typically are not permitted to do a denial of service. That would be very easy. But typically, a lot of the switches, they will have port fast turned on, where span tree is disabled to the users. Totally cool. But there's been no protections put in place like BPT guard and root guard to stop somebody from, with just very novice skills, just came out of a basic security class or, or downloaded backtrack and start doing your Yersinia attacks against you and start announcing themselves on the wire with a higher priority for the root bridge. So you want to go and look at locking that switch down with BPT guard and root guard to stop that type of stuff. Kill those, lock those switch ports down so that if they're not a trunk port, disable it. Get rid of that dynamic auto-negotiate. Auto-negotiate is your enemy. I've seen a number of network guys in my career end up getting to find new jobs because of the auto-negotiating capabilities of switches, because it ends up burning them. In their case, it was performance, it wasn't security, but there's nothing to stop Yersinia from tearing that apart. And then I see a lot of the network devices that you can do it with. They'll feel back. I mean, you got a lot of this stuff out there. People get, network guys, we get the stuff in place. We don't change it. And, blinky lights work. I mean, and when you get it in there, you don't change it. Being a router guy, we never upgrade our configs, or not so much our configs, but our OSs. That's for the operating system upgrades are for the Windows guys. As router guys, we don't have to do that stuff. Though we should. Some things to look at is to stop some of these layer 2 threats is learn about private VLANs so that you can isolate trust relationships inside of a flat network. If you inherited a flat network that you can't go back in and add segmentation to, private VLANs could help you out. VLAN ACLs would be good. Something to make yourself aware of if you're not aware of it is DHCP option 82. If you're having problems tracking down problem users, if you got some phantoms that are coming in and out of the network, and you got a DHCP network, look at option 82. You got to have a DHCP server that'll support option 82. But what option 82 will do is whenever a user sends out a DHCP request, it will inject into the header of that DHCP request the chassis name, the name of that device, and the interface port number that it's coming from, so that you can track down very quickly where that problem IP address is being sourced from, especially if you're in a very large campus, say like a university, where it's hard to get people in. Look at getting layer 2 network flow on your network, and really go and look at understanding your information flow and the trust relationships. I mean, why would your printer, your print server, and majority of your servers for that matter, need to have traffic flows out to the internet? I mean, but we go and we got a firewall, right? Just, turn on NAT and PAD and let it rock. But because of that, the networks are getting very easily owned, enabling lots of pivoting. Bottom line, is what I'm pushing really hard is to, everybody's talking about whitelisting the applications. I agree, that's a great place to start, but we really need to go further and whitelist the network trust relationships. If something's communicating, have it hard documented, what needs to communicate, why it needs to communicate, and if it doesn't need to communicate, put in some ACLs, either layer 3 ACLs or layer 2 VLAN ACLs, and private VLANs to lock down those trust relationships on who can communicate, and then go a step further and configure the IDSs if they're smart enough, if they give you the flexibility. Get your IDS to go and monitor and whitelist the flows that are trusted. Who should be talking to who, and anything outside of that data set of what is trusted should throw an alert to you. And it probably would make the monitoring easier. That's what I have today. Any questions? Yeah. Well, I wasn't going to market or push a vendor today, but what I'm aware of is Cisco ICE. I mean, I'll just give a disclaimer: we're a Cisco partner. I know Cisco. That's what I know really well, or I hope I know very well. That's what I tell people. That's what I market myself as a Cisco guy. I know the ICE, and the ICE is really good stuff. There may be some others. I just don't work with them. Only so many hours in the day, and that's what we resell. So. But if you are a fan of Cisco, the Cisco ICE is a great solution, especially to get down to those endpoint devices and lock down those trust relationships. There may be some other vendors that work very well. I'm just not aware of them, haven't had the opportunity to work with it yet. But ICE is great. Any other questions? Well, people see the disruptions. It may not hit the news, but they're out there. I mean, I see them. My phone rings all the time. I was answering the phone as I was driving through the Carolina mountains, talking to someone about a problem like this. So, what the reason you don't probably see really major disruptions because these things are happening at the spokes. They're not happening at the core. This stuff is not happening with your Quest, your AT&T, your Sprint, because they got huge network staffs, huge security staffs that understand these things. The things that I presented, where I see these things happening, is out at the spokes, so it's very localized. So what I want to do is make people aware of it, so that when you go back to your network that you're managing, the network you may be managing tomorrow, you can go in and work with the vendors and start asking them some hard questions about the accesses that they may have into your network, so you can go back and lock them down, or help your local community to go and ask the hard questions that they just didn't know to ask. They didn't know. The economics are pushing them to go and implement all these things, and quite honestly, the vendors in a lot of cases are taking advantage of them. And a lot of times the vendors don't know about the threat. They're just trying to make their stuff work like everybody else. It pings, I got a green light, it works. Reporting's working, ping's working, billing's working, people are getting paid, customers are paying their bills, things are right, the TV's working, they're hearing the clicker and the CO, and they're watching the channels change. Hey, it's great. But they don't understand that threat that they may have inherited and brought in when they brought all those systems together in one place. So hopefully this will go and give the community some good information and some good questions to ask the vendors, and some stuff to put into their RFPs, so that when they write an RFP and start writing their requirements, that the vendors will know going in that they're not just going to roll over the customer and just put in whatever network architecture they want with whatever free access that they want. No, get it in writing up front that you're going to agree to these policy standards. before dropping off, you know, your truckload of systems. Right. What happens when I say spoke, I'm talking about an organization. I'm talking about a spoke organization that's like a tier 3, tier 4 organization. And a lot of times what happens is they don't have support until their fingers do the walking, or they find that business card of the trusted network guy that can hopefully, you know, remote in or drive in to provide them a hand and get the network recovered. Any more questions? I appreciate you guys letting me speak to you. I hope everybody got something out of this. Thank you.